Yes, you can.
Thank you, sir, for the opportunity that you gave us to present our presentation as Group 4. And hello, everybody. Welcome to our presentation. Group 4, our topic was sequences and strings. So we are going to share with you um, the findings that we gathered for this presentation for this topic. Right. So what we are going to talk about today, we're going to talk about sequences. What are sequences? Their definitions, the types of sequences that we have, and some operations that are done on sequences. Then we are going further to talk about strings, the definition, types of strings, and also operations that are done on strings. Then we are also going to give you just a typical exam question that we found in one of our past exam papers. And we also have got some bonus information that we are going to give you as Group 4. So without wasting much of our time, what is a sequence? The definition of a sequence is sequences represent an ordered list of elements, typically in numbers. The notation A subscript n represents the image of the integer n. We refer to A subscript n as a term in the sequence. And sequences can be finite with a limited number of terms or infinite with unlimited number of terms. I would like you to take note of the word order that we put in bold there. So examples of an infinite sequence, we can have 4, 8, 12, 16, up to 64. So you can see that this one is starting from 4 and limited to integer 64. And then an infinite sequence can be any sequence that does not have an end. So for example, this one is 1, 2, 3, 4 until infinity, right? We have got different types of sequences. The first one that we are going to talk about is an increasing sequence. An increasing sequence is a sequence of numbers in which each term is greater than the preceding term. In other words, a sequence A subscript n is increasing for every index n is greater than or equal to 1. So the notation for an increasing sequence is A subscript n is less than A subscript n plus 1, which means the number that is following the first element of the sequence will be greater. An example is the sequence 1, 2, 3, 4, 5 is an increasing sequence because each term is greater than the one before it. Right, then we go on to the next one. We have got what we call a decreasing. A sequence can be a decreasing sequence. In a decreasing sequence, each term is less than or equal to the preceding term. So mathematically, if A subscript n represents the nth term, and A subscript n minus 1 represents the term immediately following it, then a decreasing sequence satisfies that A subscript n is greater than or equal to A subscript n plus 1 for all A subscript n. So for example, the sequence 10, 8, 6, 4, 2 is a decreasing sequence because each term is less than the previous one. Now we go on to subsequences. We have got also what we call subsequences. A subsequence is a sequence that can be derived from another sequence by deleting some elements without changing the order of the remaining elements. For example, consider the sequence A subscript n, which is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. A subsequence of A subscript n can be B subscript k, which is 2, 4, 6. You can see that we have taken 2, 4, 6, 8 from the first sequence, which has got 1 up to 9. So 2, 4, 6, 8 can be a subsequence of the first sequence. So this subsequence is formed by taking the elements at indices 4, 2, 4, 6, and 8 from the original sequence A subscript n. Right. We are still on types of sequences. We've got what we call an arithmetic sequence. An arithmetic sequence is a sequence of numbers in which the difference between any two consecutive terms is constant. This difference is called the common difference, and the general form of an arithmetic sequence can be represented as A subscript n is equals to A subscript 1 plus in brackets n minus 1 times D, where A subscript n is the nth term of the sequence, A subscript 1 is the first term of the sequence, and D is the common difference, and N represents the position of the term in the sequence. We are going to give you an example. Example of an arithmetic sequence. Consider the arithmetic sequence with the first term A subscript 1, as we have said in the slide that we were on. We said A subscript 1 represents the index of the numbers that are in the sequence. So, for example, they are saying here A subscript 1 is equals to 3, and the common difference between the elements that are in the sequence is equals to 2. We want to find the first 5 terms of this sequence. So using the formula A subscript n is equals to A subscript 1 plus in brackets n minus 1 times D, we calculate the terms as follows. So we are given already that on 1, A subscript 1, we've got 3. So for us to get A subscript 2, we then say A subscript 1 plus D, which is equals to 3 plus 2, which is equals to 5. So what we are saying, we are just taking the 2 and putting it on the values where n is. I hope you are getting me. So for example, the first example there, we are saying that the A1 will be our 3, and then our D we are given already, that is 2. And then minus 1, and then we multiply by our D. So for example, if we want to get A3, we are saying the 3 plus the 2 was already, if we subtract 3 minus 1, we get 2. Multiplied by 2, then 3 plus 4, which is equals to 7. Same applies with A4. We are just taking the 4 that we have as our nth term and put it into the brackets 1. Then we say 4 minus 1, we get a 3. Then we multiply by our given D, which is 2. Then we are saying 3 plus 6. Then it gives us 9. Same applies with A5. I hope the example that I've given is clear enough.
Look, so, I have a question there. I have a question. The
right,
question that I have, you are saying you are using the formula AN is equals to A1 plus N minus 1 times D. Can you quickly explain what is AN?
Okay.
As what is A1?
All right.
As what is N and what is D? I think we need to know also the arithmetic sequence can be also called arithmetic progression. Just those two names, they can be used interchangeably. So you can see in your exam maybe being it referred to as an arithmetic progression or arithmetic sequence. So I just want you to quickly explain AN, A1, N, and AD there.
All right, sir. Thank you. Thank you for that addition. So if we see here, we are saying the last, I'm going to explain using the last statement that is written on this slide. We are saying where A subscript N is the nth term. So we are saying the nth term of a sequence. We are not given like a position to say maybe find the 20th term of that sequence. So we are saying this AN, which is here, can represent like 1 or can represent 10, can any number or any position of our sequence. That's AN. Then A1 is the first term of the sequence. So for example, if our sequence is starting with 1, 2, 3, the first term will be 1. So that's A1, which will be our first term of any given sequence. And then the n that is in the bracket is the same n that will be here on AN, because we're saying it is giving us the position of that number in the sequence. So for example, if AN here is 20, which means this n is also going to be the 20, because it is the same, and the same number that we are using for a subscript n will be the number of the n that is in the brackets. And then the d that we are saying here is a common difference. So for example, let's say if our sequence has got numbers 2, 4, 6, 8, 10. What is the common difference between these terms? So we can see that from 2 to 4, we have got 2. From 4 to 6, we have got 2. From 6 to 8, we have got 2. And from 8 to 10, we have got 2. So the D represents the common difference of these numbers. So in the example that I've given out now, it will say, it means our common difference will be a 2. I don't know if I've explained it correctly, sir.
Yes, that's what I wanted you to explain.
All right, thank you, sir.
I think it will be now clear for everyone.
All right, sir, thank you. Yeah. All right, so this one I had explained the example, right? Still going with our types of sequences, we've got what we call a geometric sequence. A geometric sequence is a sequence of numbers in which each term after the first is found by multiplying the previous term by a fixed non-zero number called the common ratio. So the general form of a geometric sequence is given by A subscript n is equals to A subscript 1 times R, which is the ratio, to the power n minus 1. So you will see that with this one, it is the same with the arithmetic, but the only difference is that we now have got what we call a common ratio, right? So a non-zero, this common ratio will be a non-zero number, which is found by multiplying the previous term, you see. So we are saying where a n is the nth term of a sequence, a1 is the first term, and r is the common ratio, and the n is the term of the number. So as we have explained on the arithmetic, I'm just going to give you also another example for the geometric. Right. So here we are already given our A1 and our common ratio, which is 2. So maybe the question will be considered this geometric sequence where A1 is 3 and our ratio is 2. The terms of the sequence will be, so they are saying find the terms of the sequence using A1 as 3 and our common ratio as 2. So we are saying then we are just multiplying the previous number with our common ratio. So for example, we are saying here, A1 we are given already 3, and then on A2, we are now saying A1, which is our 3, times the common ratio, which is 2. This is going to give us our 6. Same applies with A3. So it's one and the same with the previous one, but this one we are only using a common ratio that is already given. So if you take this the same example that we are given here, it will be just like what we are doing here. So we are saying
sorry to interrupt. Praise Zonge, may you please turn off your camera. Let's make sure that you are all on mute and you turn off our camera. Let's switch off our camera. I'm sure there's praise Zonge. Yeah, thank you for that. You can proceed. But also before that, I think I've asked you to add some formulas for the.
I got it.
You have got it.
Yeah, we just got it. So I've added them now on the slide. So that's the ones that are coming now.
Oh, but they were supposed to be for the arithmetic progression. They were supposed to be a sum to n formula, and as well for the geometric progression, the geometric sequence.
Yes.
Can be also called the geometric progression. So I was thinking that they were going to be in that order, not to mix them up. But anyway, it's okay.
All right, my apologies there. All right. Right. So let me just just jump to that slide that I've edited, and then we can go to the summation. Or maybe I can explain this summation and then we go to the formula that you had.
It's okay. It's okay. You can finish on the geometric sequence, no problem. You can finish on the geometric sequence, then you can go to.
Okay.
Okay.
All right. So I was just explaining to say, for example, if we are given consider the geometric sequence where a1 is 3 and the common ratio is 2. How do we find the other terms of the sequence? So we are saying our a1, I think what we just have to understand very well is that a1 is representing the first sequence, the first term of the sequence, a2 is representing the second, a3 the third, a4 the fourth, and a5 the fifth. So what we are saying now, we are saying on a1 we have got already a 3 that is given. If we multiply it by 2, we are going to get a 6. So that means we have multiplied the first term with the given ratio, that is 2, to get a 6. But now remember that on a3 we are now going to have a 3, but it's going to be, is now a 6 that is going to be multiplied by 2 to give us a 12, because every term that we have is multiplied by the common ratio, which is 2. So every next item is going to increase with the common ratio that we have, because according to our formula, we said we are multiplying it by the ratio. I hope that one is making sense. So in this sequence, each term is obtained by multiplying the previous term by the common ratio 2. So the sequence generated starting with 3 and multiplying each term by 2 will be 3, 6, 12, 24, and 48, because we're just multiplying each term by a given common ratio.
There is a hand by Rudo. There is a hand by Rudo. You can unmute yourself and contribute or ask. I think you have the same question as me. You can ask, Rudo. Rudo Msano.
Okay, sorry. I want to ask, where do we get the common ratio and how to get it?
Okay, the question is on how can we get the common ratio R? That's the question there.
Okay, that is the given
also,
question.
Majita, may you please turn off your camera? Majita, may you please turn off your camera? Majita Rugoa. You can answer. Look.
Okay, so I don't have like a formula on how to get. We did not work on that one, but I'm going to answer using like my own knowledge that I just gathered when we were studying this. So, for example, if we are given a sequence already, the example that I've given you is the one that we are given already a common ratio. But let's say we are given a sequence already, then we are supposed to find a common ratio. We have to look on the numbers that we have now to see what exactly is happening in terms of this one. Because from the formula, you can see up on the given formula, you can see that we have got already using our knowledge on equations. Will be given, for example, here a 3. So let's say our an is 3 is equals to our a1, for example, will be 6. But they are saying our common ratio here, we have got an r and then n minus 1. So we are saying 3 here, we are going to plug this 3 on the n minus 1 to get a 2. So this will be r squared. Then we are going to say here, our 6, we are now taking the 3 that we have here.
You are not answering the question. The question was, how can we find the R given a sequence? If you look at the answer that you've produced the answer there. You've got 3, 6, 12, 24, 4, 8, and then 48, which means that sequence is a geometric sequence. If you are given that sequence, how can you find the R there? That's the question. So the answer is that if you want to find the R, you just say the nth plus 1 term divided by the n term to get your R, which means you just say the next number divided by the previous number, the next number divided by the previous number. If you can just take two consecutive numbers and take the other two consecutive numbers, you can confirm that this is a a GP, or that this is a geometric sequence, by just dividing those two numbers, those numbers. Like if you say 6 divided by 3, you get a 2. If you say 24 divided by 12, you get a 2. If you say 48 divided by 24, you get a 2, which means your R is 2. That's your common ratio. Also, the question that I want to ask you for this one is that you have given us a formula, but you didn't use it. I didn't see you saying we've got a r to the power n minus 1, where a is the first term and then n is the position. So I didn't see you doing all that.
Yeah, the calculation part of the n minus 1. Yes, that
Exactly.
one we also noticed, but we're trying. Our apologies on that one. We're supposed to give you an example that has got all the information on that one.
Yes, then there is a hand by Russell. You can ask or you can contribute. Russell got it.
Hello. I wanted to add on where I wanted to contribute about the ratio. So you have explained it already.
Okay, thank you for that. Then so look, I think you can just demonstrate. You've got your A1, which is the first term of the geometric sequence, as 3, and you have got what do you have? The common ratio you have been given is 2. I want you to find the A2, A3, and A4 and A5 using that formula. Remember, the formula is AN is equals to what? Is equals to A times R to the power n minus 1. And you are given A1 is 3 and R2 is what? Is 2. And the N you have it because you want to find the second number of your term, the second term of your sequence. So how can you do that? So you want to find the second, the third, and the fourth, and the fifth. So how can you substitute those values? That's what I want you to demonstrate there. Maybe
Okay.
for the first 3 terms, you've got the first term, so add the other 2 terms
Okay.
using that formula.
Okay. So we are saying here the first term is 3. So which means here, for example, I'm going to use here. So we are saying our AN, it will be A1. So it will be A1 is equals to 3 times R to the power 1, because we said our N is 1. 1 minus 1, which is equals to, because our R is 2. Then if you say 1 minus 1 is going to be 0, so we are going to have a 2 to the power 0, which is going to be our 1. So we are going to say 3 times 1. Then we are going to get 3. Then when we go to 2, we are going to say A, then our N is going to be 2, which is equals to our A1 is 3 times our ratio 2 to the power 2 minus 1. So we are going to have 2 minus 1. So our ratio will be 2 to the power 1, which is 2. So we are now saying 3 times 2. Then we get the 6. Then if we are going to 4, our AN is going to be here. Our N is going to be 4, which is equals to 4 is, and then we are going to say it is equals to 3, which is our A1, times our given ratio 2 to the power, the value of N will be now 4. We are now going to say 4 minus 1, which is 3. So 2 to the power 3 is going to be 2 times 2 times 2, which is going to be 8. So we're going to say 3 times 8, then we get a 24. Same applies with our 5. Our N here is going to be 5. Then we say equals, our A1 is not going to change, it's the given 3 times our ratio 2 to the power 5 minus 1, which is now 4. Then it also goes to the next sequence and to the next sequence.
I think that's all what I wanted.
Thank you, sir.
Okay.
All right. So we have got what we call summations, summation of sequence summation. So sequence summation refers to the process of adding a sequence of numbers together. In general, the sum of a sequence is defined by the summation So the n and m here are representing the lower limit of the sequence, and the n is representing the upper limit. So we are saying, I'm going to explain this one with the information that is given that we wrote on below, where k is the index of the summation. So what are we saying when we say the index? We are saying 1, 2, 3, 4 in terms of the position of that term in the sequence. So this is going starting from m to the upper limit of n, represented by k is equals to m, and that n that is on top of our summation mark. M and n are the lower and upper bounds of the summation respectively, and ak is the term being summed at each index. So I'm going to give an example. Calculate the sum of the sequence from 1 to 5. So as you can see, our lower limit, which is represented by k is equals to 1, is 1, and then the upper limit is 5. So this means that we have got 5 terms in this sequence. So how are we going to do this? We're just going to our k, as we have said, this k is representing the index of the summation, which goes, so we are saying 1 plus 2 plus 3 plus 4 plus 5, which if you add all these terms, they are going to give us 15. I'm just want to put a okay, let me carry on and then we'll go to the next slide. Right, on the summation, do you have any questions, or can I proceed? Thank you. I think the silence.
You can proceed.
All right. On the products, right? We've got our sequence product. Sequence product refers to the process of multiplying a sequence of numbers together. In general, the product of a sequence is defined as, so we've got the product sign. It's one and the same with the summation one, where k represents our lower limit and n our upper limit. So k is the index of the product, which goes from n to n. M and n are the lower and upper bounds of the product respectively, where ak is the term being multiplied at each index k. So the same, I'm just going to give you an example, which is at the bottom. Calculate the product of the sequence from 1 to 4. So we are saying we're going to start from 1 and going to 4, right? And then our numbers that we have, our terms of the sequence are 1, 2, 3, and 4. Then we are just going to say 1 times 2, 3 times 4, 2 times 3, 3 times 4. These are just examples. So please note that on the, maybe on other examples, you can have different terms that are not 1, 2, 3, 4 as the given example. Right. So this is a formula for the summation of an arithmetic sequence. And then the summation of the summation formula of an arithmetic sequence is given by S subscript n is equals to n divided by 2, and we've got those square brackets, 2a plus n minus 1 in brackets times d. So I'm going to explain Sn is the sum of the first n terms of the sequence. A is the first term in the sequence. So if you still remember when we talked about the arithmetic sequence, we also talked about the first term, which is A1. So A is the first term in the sequence. D is the common difference between consecutive terms, and N is the number of terms in the sequence. So for example, in the sequence, if we have got 5, so wherever there is n, we are going to put 5. It's just an example. Let's say our sequence have got 5 terms. So wherever there is n, we are going to plug wherever there is n, our number 5 of those sequences. Unfortunately, we did not put up an example of this, but we really wanted to put an example of how to work on this formula. Apologies for that one, because we managed to do this afternoon after the request to add this formula. So, but I hope it I've managed to explain it very well so that people can understand.
So guys, I think the class needs to research more on this and work more on this, but the idea is just simple. If you are being asked to find the sum of the first n terms of a given sequence, what you just need to do is to know, is the sequence an arithmetic progression or an arithmetic or a geometric progression. If it is an arithmetic sequence just like this, you can just use the sum to n formula, which is Sn is equals to n over 2 by 2a plus n minus 1 times d. And you know that from this formula, your n is the position, and a is the first term, and d is the common difference, just like that. So what you just need is to plug in your values. So sometimes you might not be given some of the values there. So you need to find them first and then plug in the values and just work out the result. By doing so, you'll be finding the sum to n. So it's just like the summation, like what you have actually explained before when he was trying to find the summation of a given sequence. So you can use this formula to find that summation of the first given any terms. So instead of adding one by one term, you can just have the value for n and the value for the first term and the value for the common difference. You can calculate the sum to n just like that. You can proceed.
Okay, thank you, sir. So just to add on this one, let's say we have got, they are saying a summation of the first 5. So we are just saying n is the number of the terms. So the first 5, which means it's going to be 5 over 2. Let's say that the first number of the sequence is 3. We're going to say 2 times 3 plus 5 minus 1, and then with a common difference of 2. I've just taken these numbers from the previous example that we have given. So we're just plugging in into those numbers. Right. Then another formula is the summation. This one is the summation of a geometric sequence. So that one was the summation of an arithmetic. Then for a geometric sequence, we are saying it's Sn is equals to A. Then in those big brackets, R to the power n minus 1 over R minus 1, where Sn is the sum of the first n terms of the sequence. A is the first term in the sequence, R is the common ratio between consecutive terms, and the N is the number of terms in the sequence. So just like the summation formula for the arithmetic sequence, this one now is the summation formula for the geometric sequence, where A will be the first term of the sequence, R is the common ratio like we have talked about in that previous slide, and n is the number of the terms in the sequence. So if they say find the summation of the first 5 terms of this geometrical sequence, wherever there is n, we are just putting that 5. And then we take the a as the first term of that sequence, and then we calculate so that we can find the summation of those first 5 terms. Moving on, we felt that we should just put this difference, the sequences versus series. So a sequence, I'm just going to read aloud these differences. So you're saying a sequence is defined as successive arrangement of numbers in an order according to some specific rules. And then a series is formed by adding the elements of a sequence. So those adding of the order, that is what we call a series. 1, 2, 3, 4, 5, the addition of those elements that are given in a sequence. Sequence, it is basically a grouping of components that follow a certain pattern. Like we have said, we're talking about a common difference of 2, 2, 2, 2. So it's following a certain pattern. And then a series is the sum of elements that follow a pattern. Then in a sequence, the order of the numbers is important. Like what I said from the first slide, the order of numbers in a sequence is very important. Either is increasing or is decreasing, and the common ratio in between. In a series, the order of numbers is not important because we are just adding those numbers. So at the bottom, the last row has got examples: an infinite arithmetic sequence 3, 5, 7, 9, and then an infinite arithmetic series. We're just adding the 3, 5 plus 7 plus 9 plus 11, then we get. Then an infinite geometric sequence 2, 4, 8, 16. Then an infinite geometric series 2, 4, 8. We're just adding. So series are just the addition of a given sequence. Right. We are now moving on to strings. Right. A string is defined as an arrangement of symbols from a given alphabet where the symbols may or may not be distinct. Characters in a string can be represented using subscripts like S1, S2, S3 up to Sn. Then a string over X is finite sequence of elements from X. For example, let X be A, B, C. If we let S1 to be B, S2 to be A, S3 to be A, and S4 to be C, we obtain a string over X. This string will be written as BAAC. So where did we get the BAAC? We are just saying the subscripts given from the X set that we have here. We have got S1 described as B, S2 as A, S3 as A, and S4 as C. So this string came about, the BAAC came about considering the positions of the letters that were given on top. So we are obtaining this string over the given X, which is BAAC. There are also operations that we can do on strings. So the first operation that we are going to talk about is what we call concatenation of a string. So concatenation is the operation of joining two ends end to end. So given two strings A and B, the concatenation of A and B is denoted as A dot B or simply AB. For example, if we are given A as yellow and B as white, then the concatenation of AB will be hello world. In strings, we also have got what we call substrings. So a substring of a string A is contiguous sequence of characters within A. So we are saying, for example, in a string A, which is equal to yellow, we can get a substring L, which is part of A. So the E double L came about from our first string that we have yellow. So we are saying this L is also a substring that was obtained from taking letters from the first given string. But we have put this in red. We want the team to, you must take this one very importantly to say, let's say A is BAN and B is ANA. If we concatenate A and B, we get banana. But if we concatenate BA, we are going to get anaban, which means these two are not equal. So AB is not equal to BA. So that's the last statement that's saying, therefore, AB is not equal to BA. Right. Moving forward with the string operations, we have got what we call a string length. The length of a string A is the number of characters in A. So we are saying the length of a string is denoted by those two straight lines, like the modulo signs or something. But we are saying those are the denotions of the length of a string. So, for example, if A is equals to yellow, then the length of yellow is equals to 5. So those two parallel lines, they denote the length of a string, according to, as you can see on the example. Right. We've got also what we call repetition or exponentation. The string repetition involves creating a new string by repeating a given string n times. It is denoted by A to the power n. So I'm going to give you an example. If we say we've got A is equals to high and the n is equals to 3, then A to the power n is going to give us a string that has got those highs multiplied by 3, which is high, high, high. Right. I think we've come to the end of our presentation. We're just going to give you some typical example questions that we have taken from our ZOO June 2020 exam. The first question, on question 1, it was saying find the sum of the first 10 numbers of this arithmetic series, 1, 11, 21, 31, and then the second question is find the number of terms in the geometric progression. And then the last one that we sought was evaluate that given summation. Right. So we used we did not use the formula that we just presented, but we used the one that we had presented first. So apologies for that because we had already done this one already on the summation. So we are saying we are going to use on the first example where it is saying find the sum of the first 10 numbers. Right. So we are saying how do we get, so the method that we used here, how do we get these numbers? Right. So we're also looking at an is equals to a1 plus n to the power 1, n minus 1 in brackets multiplied by d. So if you see there, we first checked to see what is the common difference between the given numbers, like from 1 to 11, 11 to 21, 21 to 31. Then we realized that no, these numbers have got a common difference of 10. So that's why we say our numbers are starting from k1 to the limit of 10. So if we say 1 plus 11 plus 21 up to the 10th value that we want, which is 91, we get our answer, which is 460. This is how we went about through. But as
Which
our
with the
essay explained, we can
hello,
also use that summation formula to get the same answer.
look,
Yes, sir.
are you seeing that with this method you are supposed to list all the 10 elements,
Yes.
right? Just go to the previous slide. Just go to the previous slide. So if you look at that question, it's saying find the sum of the first 10 numbers of this arithmetic series. Instead of finding all the first 10 numbers and then add them to find the total, you can just simply plug the n and the d in your formula. Your n is 10. And the common difference is just 11 minus 10, 11 minus 1, which is again 10. Even if you say 31 minus 21, you're going to get a 10. So the common difference is 10.
Yes.
So the formula was supposed to be n over 2, which is 10 over 2, and you are going to get a 5. Then times 2a, which is 2 times 1. Then what? N minus 1, then times d there.
Yes.
So if you look at that formula, you're just going to plug in those values. So you're supposed to just find a d and the n, you already have it. So those numbers that you are given, 1, 11, 21, and 31, they gave you so that you can find the value of the common difference. And then you can just plug in your formula and find the sum to n, which is sum to 10 for this one.
Thank you,
Just
sir.
like
Yeah.
that.
Yeah.
So I think it's the quickest way to do that rather than finding all the 10 elements at all the 10 terms and then you try to sum them up.
Yeah, no, the
So
point has been taken.
either way you can get to the answer, but I wanted you to see that.
Exactly, sir.
Okay, you can
thank you
proceed.
very much for that one. Right. So the other example that we've given is the B part, where they are also talking about find the number of terms in the geometric progression. So now this one, you see, it's saying find the number of terms in the. So we can also use the formula that we presented, that we looked at, but for this one we had already done to find out the number using this other formula that we just tried to write. So we are on this one, as you can see, the question is saying the geometric progression has got 6, 12, 24, up to 1,536. So what we are supposed to find is how many numbers are in this geometric sequence. So as you can see here, you can also see that the common ratio of these numbers looking at 6, 12, and 24 is like two balls. We are just saying what number are we multiplying 6 to get 12? What number are we multiplying 12 to
To
get?
find the common ratio, you just say 12 divided by 6 or 24 divided by 12. You just take two consecutive numbers and you say the next number divided by the previous number. That's the formula there. You do not need to try to do what. You just need to take the second number divided by the previous number. If it is an API, if it is an arithmetic progression or arithmetic sequence, you do the subtraction to find the common difference. Second number minus previous number. If you are finding the common ratio for a geometric sequence, you just say second number divided by the previous number. Just take any two consecutive numbers, you divide any two. So for this one, you can say 24 divided by 12, you can get a 2. You can also 12 divided by 6, you can get a 2. That's the way to confirm if a given sequence is a geometric sequence or is an arithmetic sequence. So sometimes you are not told that this sequence is a geometric progression. You might be asked to find the sum to n, or you must be asked to find the n and the term of a sequence, but not being told that this one is an arithmetic progression or this one is a geometric progression. So you need to confirm, is this sequence really a geometric progression? Or is this sequence really an arithmetic progression? Just like that. So how do you do that? If it is an arithmetic progression, it have got what you call a common difference. How do you find a common difference? Second number minus previous number on a consecutive on a consecutive numbers. And then if you go to the geometric progression, you need to find a common ratio. If there is a common ratio, you know that this one is a what? This one is a geometric progression. So you just say the second number divided by what? By the previous what? By the previous number. So you just take two consecutive terms, divide the second by the previous, and then if you get the same R or the same value, if you say the second divided by, and then again you go to another consecutive, the second divided by, and if you get the same value, it means that one is a geometric progression, just like that. So that's what you do if you want to find the R there, and then from there you can proceed to your formula.
Yes. All right. Thank you, sir. So I'm not going to explain much on this one because we've got the other one that we were using on top. But so here like what Seth explained, you can see that to find the common ratio, we just say 12 divided by 6, then we got a 2. So the nth term, which is given already there, is 1536. So if you say 1536 divided by 6, we are going to get we are going to get 256. Then our common ratio is 2. If you remember, our formula is saying r n to the power minus 1. So we're going to say 2 to the power n minus 1. 256 is equals to 2 to the power n minus 1. Then if you say 2 to the power n minus 1 is equals to 2 to the power 8, which is 256. So 256 just the same as 2 to the power 8. Then we're going to take like the laws of indices. We're going to take the our indices n minus 1 is equals to 8. Then our n is given by 8. We're going to take 1 to the other side, then 8 plus 1, it gives us 9. So it means the number of the terms that are in this geometric sequence is 9.
Just like that. So you can go big. Yeah. So if you look at these guys, what
Sorry?
they have done, yes, that's what I just want to add something there. So if you look at these guys, what they have done is they just took the formula to find the n at the term of an arithmetic progression. So you want to find the total number of the terms, right? Up to the 1000, was it 1536? So how many terms are there between the from the first term up to the 1536? So they've just said our an, let our n in the term, which is an, be 1536. And then you know the first term and you know r. So what you need to do is to just find the n, which is at the power, just like that. So they've plugged in the an as what, or the n in the term is 1536, and then the first term there is 6, and the common ratio is 2, and they've used the laws of indices. If bases are equal, also powers are equal. So you have got 2 to the power n minus 1 and 2 to the power 8, which means the base is 2, so the powers are also equal, which means n minus 1 is equals to 8, and then they find the result is 9 there, just like that. So thank you for that. I think you can proceed if you have something else there. You can proceed.
Yeah. We're just going to, so on this one, we were just evaluating this one, given this question, the last one, evaluate the summation of these ones. So what we have done with this one, we just took the values of K, as we have said that K represents like the numbers or the indices of that sequence. So we've just said for K1, so we are just plugging our one, we're just plugging our one on the formula. So K1, we're just plotting where K is 1, we're just saying 1 minus 1. Then here we're just going to say 2 times 1 plus 1. So this is what we are just doing here. So we are just taking the number, we're just getting the K value here and then plugging it into the given formula. Then after that, we just have to add the results that were given, which gives us an answer 0.819. So what we have just done, we said when K is equals to 1, we just put the 1. So if you can see from what we are given K minus 1. Then here it's 2K plus 1. So we are just putting the value of K so that we get the result when K is equals to 1. Then when K is equals to 2, when K is equals to 3, and when K is equals to 4. Because we've got our lower limit as 1 and our upper limit is 4. Then after that, we are going to add all our results to get the total summation. So the value, or if they say evaluate that formula, so the answer for that question will be 0.819. And then this is the bonus one that we just talked about for those guys who are doing the computer science. We're just saying some will find out, who want to try and find out how our strings are used or how our sequence is used. So we are saying in computer science, strings, in computing, strings are fundamental data structures used to represent text. They are used in operations such as searching, pattern matching, data validation, data input, and more. Strings also play a critical role in algorithms like data compression and encryption. Sequences likewise, like lists or arrays, are used to store collections of data elements, allowing for operations like indexing, sorting, and manipulation. Data structures such as linked lists, queues, and stacks are also based on sequences. So in mathematics and statistics, those guys who are doing mathematics and statistics, mathematical sequences used in a variety of problems such as series summation, calculus, number theories, and discrete mathematics. Then in statistics, time series is data, which is a sequence of data points recorded over time, is also used to analyze trends, forecast future values, and model economic financial data. So thank you very much, guys. This is our presentation for group 4.